Good morning, class. This is Blitzer 5.1 verifying trigonometric identities. So we start out with the fundamental trig identities that we're going to be using in this section, reciprocal identities. So hopefully these look kind of familiar. Sine is 1 over cosecant. Tangent of an angle is 1 over cotangent of an angle. So all of those reciprocal identities. Quotient identities. This might be a new one. Maybe you've never thought about this before. Tangent of x is sine x over cosine x. And then Pythagorean identities. Pythagorean identities are maybe some of the most useful. So sine squared plus cosine squared equals 1. There's 3 right here. It's maybe hard to see because they're right on top of each other. Here's the first one, and the second one, and the third one. And I can actually, if I forget one of them, if I take this first one, you always have to remember the first one. And the first one I could remember because it's kind of like the Pythagorean theorem, x squared plus y squared equals r squared, where that r is 1. If you take this and you divide it all by sine squared of x, you'll get this first one. If you take the whole thing and you divide by cosine squared x, you'll get the second, or the last one. So they're all related. And then even odd identities. So you'll notice, like if I take pretty much the sine, anything of a negative x, they end up being negative except for the cosine and the secant ones. So we're going to look at verifying trig identities today. So this is what the whole day is going to be about. We're going to kind of fill in these solving tips, I think, after we go through and we solve a couple. So this is the kind of problem you're going to get. Verify that the secant of x times the cotangent of x equals cosecant of x. So we're trying to verify that. And the way these work is we work on just one side of the problem. So I can either work on just the cosecant x, or I can work on that other side, secant x times cotangent x. So our first solving tip is that we're going to work on one side only. Work on one side. Usually you pick the complicated one. So complicated, we mean just more stuff. So that means I am going to be working with secant x, cotangent x. Another thing that's sometimes helpful is to put everything in terms of sine and cosine. So I'm going to rewrite the secant of x as 1 over the cosine of x. And then my cotangent, I know that tangent is sine over cosine, so cotangent is cosine x over sine x. And I'm only working on that left-hand side, equals cosecant x. I can kind of already see how this is going. We can cancel those out. So I have 1 over the sine x equals the cosecant of x. And this is absolutely true, right? 1 over the sine x, that is the cosecant. So cosecant x equals cosecant x. So done with our first trig identity. So I'm trying to think about what other tips we use on that one. And I guess one of them would be to put everything in terms of sine and cosine. Try putting everything in terms of sine and cosine. We might have more than 5 tips. It might be interesting. So here's our second example. So again, we want to work on only the more complicated side. We don't want to work on the other side at all. We can't cross the equal sign. I can't just divide both sides by cosine of x or something. So I'm going to work on the left again, and I'm going to factor out cosine x because I see both of these have a cosine x. And now I am thinking about that Pythagorean identity where I have cosine squared x plus sine squared x equals 1. And I know that if I subtract sine squared x on both sides, I'll have this. So sometimes you need to do your little scratch work and reorganize stuff. So that means I can use that Pythagorean identity. And where I have the 1 minus sine squared x, I can substitute cosine squared x. And maybe I'll even write in that minus sine squared x. If you have trouble manipulating these in your head, or if you're just not sure, it's always a good idea to do scratch work. So now I have cosine x times cosine squared x. So if I have cosine times cosine squared, now I have cosine cubed x. And I have proven my second trig identity. All right, on our third one, definitely the more complicated side, once again, is the left. Sometimes it helps to get a common denominator. So we're going to try that, and we're going to add that to our tips. Sometimes helps to add fractions, get common denominator. All right, and I want to quickly, I don't know why there's that S over there. It must be left over from something I was doing earlier. So we'll scroll back to example 3. So in example 3, I want to get a common denominator. That means the first fraction needs to be multiplied by cosine x on the top and bottom. Okay, and the second one would need to be multiplied by 1 plus sine x on the top and bottom. So let's see. In my first fraction now, I'd have cosine squared x. I guess I'm just going to go ahead and write these as one big fraction now, because when I'm adding, I'm just going to keep that denominator and add the numerator. So my denominator will be cosine x times 1 plus sine x. And then I've got the 1 plus sine x. And that's going to be squared. So I'm going to go ahead and expand out that 1 plus sine x squared. Oh, parenthesis here. So a lot of times you're not really, like the last couple were shorter and I could maybe kind of see what I was doing. This one I can't. So sometimes you just kind of have to go for it, and you'll even have to go back and possibly erase. So the 1 squared plus 2 times 1 times sine x, so 2 sine x plus sine squared x all over cosine x times 1 plus sine x. All right, let's see. So I have that Pythagorean identity, and we're going to just keep going back to those. Pythagorean identity that cosine squared x plus sine squared x equals 1. So that means I can take out these two and substitute in a 1 instead. So I'm going to do that. So now I'll have 1 plus 1 plus 2 sine x. All right. And now I'm going to go ahead and add those together. 2 plus 2 sine x. And this is going well. Now I'm kind of starting to see what I need to do and what my answer is going to be. So I can tell I could factor out a 2 in the numerator. And then I'll have a 1 plus sine x in the denominator and the numerator. So those can be canceled out, that common factor. And let's see, we'll have 2 over cosine x equals 2 secant x. And if I have 2 over the cosine, reciprocal of cosine is secant. So this is just 2 secant x equals 2 secant x. So I think maybe that last tip would just be that, sometimes you're not really sure where you're going. There's multiple ways to solve these. That's another thing to keep in mind. But sometimes you just start solving and see what happens. We've got 2 more examples. So on example 4, man, they look pretty similar, but I think I'm going to start on the right. It seems easier to start with that minus for some reason. So I'm only going to work on the right this time. I guess maybe either way around it would be easy. So I'm thinking about how, with my Pythagorean identity again, identity, if I have cosine squared x plus sine squared x, it equals 1. And so if I have, if I subtract cosine squared x on both sides, my sine squared of x equals 1 minus cosine squared x. And then I'm thinking about how this is like difference of squares, where 1 minus cosine squared x I could write as 1 minus cosine x times 1 plus cosine x. So because there's already a minus on this side, I'm thinking, what if I multiplied the top and bottom by 1 plus cosine x? And I really should have written this as one more line. So let's do that. I don't want to start writing at the original problem. And I could have just as easily worked on the other side and multiplied by 1 minus cosine x instead. So I'm going to multiply by 1 plus cosine x over 1 plus cosine x. So let's see. In my numerator, I've got that difference of squares pattern, 1 minus the cosine, 1 plus the cosine. So I'm going to have 1 minus cosine squared x. In my denominator, I will have sine x times 1 plus cosine x. And then I'm going to go ahead and substitute now, like we planned on doing with the Pythagorean identity. So the numerator is going to be sine squared x. Oh, I can kind of see where we're going now. This is that 1 plus cosine x I want in the denominator. I've got a factor of sine that I can reduce by. So let's go ahead and do that. So sine squared divided by sine. Now I just have sine in the numerator. It's gone in the denominator. And I'm done. That's what I set out to get. So sometimes we don't actually rewrite that other side every single time. We can be done anyway. I don't have to keep writing it. It's kind of nice if you do, but it's not necessary. So last one. So on this one, I can see the 2 fractions on the left. I'm going to go ahead and try to add these together. So that means I would need to multiply, let's see, the first one by 1 minus cosine x over 1 minus cosine x. And the second one by 1 plus cosine x over 1 plus cosine x. Let's see, times 1 minus cosine x. Oops, I did that wrong. And this is going to equal 2 plus 2 cotangent squared of x, hopefully. So this might be a good time to just write down what that identity is with the cotangent. So the one with the cotangent is, I have a Pythagorean identity of 1 plus cotangent squared x equals cosecant squared x. So that might be something I might use, because this looks kind of like 2 times 1 plus cotangent squared x, or 2 times cosecant squared x over here. So if I multiplied this whole thing by 2, I'd have this. So that means I could try to get 2 cosecant squared x on this side, and then I'd be kind of there. So sometimes it helps to kind of look ahead. So I can only work on this left-hand side. I can't cross and also work. I can't substitute and write that on the right-hand side, but it gives me an idea where I'm going. So now with this first fraction, I would have 1 minus cosine x. My denominator is 1 minus cosine squared x. And then plus 1 plus cosine x over 1 minus cosine squared x. So remember, when we multiply 1 plus a cosine times 1 minus a cosine, difference of squares is what we're going to get here. So now, let's see. I can put those together in one fraction. Oh, this is kind of interesting. 1 minus and 1 plus. So when I add them together, I'm just going to get 2 over 1 minus cosine squared x. And I should know by now that when I have 1 minus the cosine squared x, that's back to that Pythagorean identity. Pythagorean identity where we have cosine squared plus sine squared of x equals 1. And then if I subtract by cosine squared x on both sides, and now I would have sine squared. So I'm going to write this as 2 over sine squared x. So now I know that reciprocal of sine is cosecant. So 2, something happened with my draw thing here. So this should be 2 cosecant of x. And it is not going to let me write. But that would be my next step. I would write 2 cosecant squared x here, because my sine squared is in the denominator. And then after that, I would write 2 times 1 plus cotangent squared x. And then I would substitute cotangent 1 plus cotangent squared for cosecant. And then I would go ahead and distribute that. So I don't know why, but my thing is just completely not going to let me draw anymore. And I have no idea why that is. So you'll have to hopefully finish up that last one on your own.